Right, ladies and gentlemen. Very few ladies and gentlemen today. Okay. Any questions? Ooh, yeah, Meersley. No, you do not have to look at section 2.5 for the test. It's only sections 2.1, 2.2, 2.3, and 2.4. Juffrou Coetzee. Which one? Right, here is a question. Quicksort with two-way partitioning, all the keys are equal. Linear? What does Google say?
I'm actually relative to million integers, and it's still like it's sorted in 2 seconds. So.
You are come. I want some comments from the class. We're doing quicksort, not three-way, standard quicksort. All the keys are equal. Yes. What is my time complexity? Oh my. Sulke goedjies is in die toets. These kinds of questions are in the test. Send me an email, I'll send you the answer. Right? These are very typical test questions. So please, please, please. Hier is julle my klas. Sien julle like anders as julle eerstejaar foto's. I can't help it. Okay. Any other questions on sorting? Right. I just have one administrative comment. Git. You have, after the test on Friday, you have to test your Git. If it does not work, you have to send an email to the technical assistant. Yes, Andrew Collette. If you don't have his email, ask one of the demis until you get his email. Then you have to re-go through that process, right? Because by next week, Wednesday, in other words, in exactly 1 week's time, you have to submit your project using Git. Test your Git on Friday, please. There's always 2 or 3 people where it doesn't work, right? So please make sure that it works. If it doesn't, get Andrew's email. If you send in an email, he'll try. If he tries and it still doesn't work, then you come and visit him in the computer science department, right? And you sit there until you've got it sorted out. Right? You have to submit via Git. Meneer Thesen, werk jou Git. Ja, syne werk. Okay? Right? Good. So up to now, with sorting, which you are all now experts on, hopefully. Sorting, what did we have? We had a data structure, typically an array with values in it. And then we sorted the values. But searching is somewhat different in the following sense. Consider for the moment you are looking, what's 'n verklarende woordeboek in Engels? What kind of dictionary? Not the bilingual one, the other one. It's just, oh, okay, a dictionary. You have a dictionary. What you want to know is you want to search for a word that you want to know the meaning of. Yes? So we have two things. Okay, almal lag nou omdat ek nie geweet het wat 'n dictionary is nie. Everybody's laughing, so just quickly get this. When we get to searching, there's a difference. With sorting, we worked with a value, and we sorted the values. With searching, there is a key. There is something that we search on, and once we find the key, there is a value associated with the key. So we are going to talk about key-value pairs the whole time. Like in a dictionary, I have a word. I want to know, what does susurration mean? Do you read the refraction? Ah, yes, susurration. What does that mean? I don't know. So I search on the key. I hope I pronounce it correctly. Okay, so I search on my key, and once, which is susurration, the word. And once I get there, I read the meaning. That is the value. So we are now looking at things where I have a key value pair. Okay? And the book likes to call the abstract data type, where I store key value pairs, for the explicit purpose of searching. The book calls these kind of abstract data types symbol tables. Comes from compilers. Next semester you're going to look at compilers and then it will start making sense. Okay? Ag nee, Here, dis nou stupid ding om te sê. In a compiler, how does the compiler know that you didn't declare a variable? Yeah, it keeps a list of all the declared variables. The moment it sees a variable name in the code, it goes to this thing called the symbol table, and it looks at that variable name to check whether you did declare it, and by the way, what is the type. Okay, that's called semantic analysis. So that's another example of, that's a classical example of a symbol table. The dictionary is another example, and there are a few more. So key value pair, and the idea is I search on the key, and then I find, once I find the key, I have the value. Okay? Right. So what do we want to do? If that is my abstract data type, what would my API look like? Well, as I said, basically I want to search. The whole idea is searching. So I want to find the key. Or, as the book calls it, I want to have a method get. And get works on the key, right? And then there's a few administrative other things. I would like to be able to initially create my symbol table. Therefore, I need puts to insert into the symbol table. I might want to delete a certain key. I might want to know, is there even a value paired with a given key? I want to know if the symbol table is empty. I want to know the size, and so on and so forth. Okay, but the important thing is get. We're going to search. Okay, so the question then, if I have an abstract data type that primarily focuses on gets and will initially, hopefully only initially, do puts in between, but it might also be a a more dynamic thing, application, like a class list, somebody registers late, now I want another put. So less put operations, more get operations. What is the best data structure that I can use? The underlying data structure on which to base my abstract data type. What do we know about? We know about arrays and lists at the moment. Okay? And as you so eloquently convinced me in the test, by now you know all the pros and cons between arrays and linked lists. Right? If I talk array, searching is roughly in an array, searching a value in an array. Meneer Eis, hoe lang vat dit my om te soek in 'n array? Roughly, searching time in an array. Ooh, okay.